All right, hi Eli. So I'm just going to go over these couple of questions that you asked. So the first one, you are given this formula, and then you're told the value for n, and you need to solve for the radius. Sorry, I'm just going to go back and open up that question. So n is the number of revolutions per minute, and you need to solve for the radius in meters. So basically this is just all about the algebra, right? So just following through with basic algebra that you kind of already know to isolate a term. So we're going to substitute in our known value right away. You don't have to do this, but I like to do it because I don't know, I just find it easier to simplify things if I have all the numbers that are going to be there at the beginning. Okay, so 5.6 is equal to 42 over pi times by the root of 5 over r. So this is the thing that I'm trying to isolate. So the first thing I can do is look at what's being multiplied by, like I can think of this whole r term kind of together, right? Because it's under the radical, and that's being multiplied by this 42 over pi. So I want to move that 42 over pi away, which I do by dividing it out, right? So I'm going to end up with 5.6 divided by 42 over pi is equal to the square root of 5 over r. Then what I did, again, just because I find it simpler to look at one easy number, is I did 5.6 divided by 42 over pi and hit enter there. So that gave me 0.4188 something. 4188. And I'm just going to make sure that I maintain that decimal. And so that's equal to the square root of 5 over r. Okay, so the next thing that I need to get rid of in order to get to this r, you can't ever solve for a variable if it's being squared or square rooted. So just like if it was being squared, you would square root it. We want to do the opposite thing to get rid of this square root, which is to square it. So we want to take this whole thing and square it. And if we do that to one side, we have to do it to the other. So 4.188 squared gives us 0.175, something like that. And that's going to be equal to, now because we squared our square root, we're left with just 5 over r. Okay, so now we need to move this r away because we can't have a fraction here. So to move it away, we need to multiply it by both sides to move it to the other side. So we're going to multiply by r. Multiply by r, so we end up with r times by 0.175 is equal to 5. Okay, and now we kind of end up with the same problem, which is what always happens when the unknown is your denominator, because now we still have another number attached. So we need to divide this 0.175 away from the r. So divide both sides by 0.175, 0.175, and we're left with r being equal to 5 over, oh, sorry, I should have squared that. Let's see, 0.222, 4.1, square it. I'm behind in my calculations, which gave me 1.75. 5 divided by that gives me 28.49, so let's just say 28.5, and then the units they said were meters for radius. So the radius of the station is 28.5 meters. Okay, so it's just basic algebra working through these types of problems. Let's try number 9. So with number 9, very similar. We have t is equal to 2 pi square root of L over 4.9. And we're given the value for t is 22. And the length is unknown. So we want to solve for our variable underneath the radical. So again, plugging in our numbers, t is 22, which is equal to 2 pi times by the square root of L over 4.9. We have a number being multiplied by our radical, so we're going to divide that away first. So divide by 2 pi, divide by 2 pi. These are going to cancel out, and we're left with 2 over 2 pi. So I'm just going to put that in right away, 2 divided by 2 times by pi, which leaves me with 0.318, something like that, being equal to, now I just have this radical left, so L over 4.9. So now, same step as before, I want to get rid of this square root, so I have to square the whole thing. And if I do that to one side, I have to do it to the other. So if I square 3.18, I end up with 0.101, something like that, equals, and then the squaring got rid of my square root, so I have L over 4.9. Okay, now how am I going to move this 4.9 away so that I have L on its own? Well, it's being divided out, so I need to multiply both sides by 4.9. 4.9. And so I end up with, times by 4.9, 101 times by 4.9 gives me 0.496. Something like that is equal to L. Huh, that's weird. Where did I go wrong there? Because this is not the same numbers I got last time. Let me just go through here really quickly. So 2 times by pi. Oh, that's it, because I put in 2 here and t was 22. There we go. 22 divided by 2 pi. Sorry, okay, so that would have been given me 3.50 something. And then when I square that, I end up with 12 point, yeah, there we go, that makes way more sense, 12.25, something like that. And then that times by 4.9 gives me, there we go, that makes way more sense. So 60.07 is equal to L. Okay, so the only thing I did notice with this question though is that you get 60.07, or basically like the length is 60, I would say. The only thing I noticed is that in the question they state that hold on, let me scroll down to that part. It says, in the description of the variables, it says t is time in seconds, and they did say that this was 22 seconds, so that's okay. But then they said L is the length of the pendulum in meters, and so we get 60, and if, according to them, length is in meters, so it would be 60 meters. They ask for the answer in centimeters, and in the answer key, they gave 60 centimeters as the answer. So I think they must have made a mistake there somehow, where either they meant to say that length was in centimeters, or they meant to say give the answer. No, because they did give the answer in the book in centimeters. Anyway, somehow they messed up there between the centimeters and meters, because this is for sure the correct value, 60. And so I would just say it's 60 centimeters. So if you thought that you got it wrong because they had centimeters and meters mixed up there, don't worry about that. If you got 60, you were on the right track. Last of all, you asked about stating restrictions. So you can just, like, when I'm marking tests and stuff like that, I'm pretty not super hung up on exactly how you would write it out. So if you're writing a restriction, I would kind of just follow the general guidelines in here. Like, usually you're going to have x is greater than or equal to, or less than or equal to, or whatever, some kind of a number. And then you can also say, and x is equal to all real numbers. So you would say both of those things. If there's no restrictions, then you can just say x is equal to all real numbers, and that's it. Okay, so your restrictions just with a greater than or less than sign, and then always finishing off also that x would be all real numbers. Okay, I'm not sure if that's, like, I wasn't totally clear if that's what you were asking, just like how to write it out, or if there's a deeper question there. So if you need more help with how to state the restrictions, then just let me know. Okay, so hopefully that helps you out, and let me know if you have any more questions.